Hello guys, I hope you are doing well. Today we are going to talk about continuity of functions in real functions. So let's start with the definition. So let f be a real function on a subset of the real numbers, and let a be a point in the domain of f. So f is a real function in a subset of real numbers. So the first thing, we have a function, a subset of real numbers, and a point of the domain of f. So we say that f is continuous on a if the limit when x goes to a of our function f of x is equal to f of a. Using the right hand and left hand limit, we say that f is continuous on a if the limit when x goes to a plus of f of x equals to the limit when x goes to a minus of f of x equals f of a. So here we have just the limit of f when x gets closer to a, and this is equivalent to this because this means this doesn't take into consideration if we are coming from the left hand or the right hand side, and here we detail from which side we are getting closer to a. So let's take some easy examples. So first of all, let's take f of x equals to x squared plus 1. So x squared plus 1, if we take, for example, the limit when x gets closer to 1, we are going to get 1 squared plus 1, which is equal to 2, which is equal to f of 1. So we have the limit which is equal to f of 1, and then f is continuous on 1. If we take another example, which is f of x equals 1 over x, if we take the limit when x gets closer to 0 plus, we are going to get f of x equals plus infinity, and limit of f of x when x goes to 0 minus, which is equal to minus infinity, then we notice that the limit when x gets closer to 0 plus is different from the limit when x gets closer to 0 minus, and then f is not continuous in 0. So let's take another definition. So we just talked about the continuity in one point. Now we are going to generalize this to an interval or a subset. So let f be a real function on a subset of the real numbers, and let I be a closed interval in the domain of f. Let I be the interval BC. We say that f is continuous on I if for every a. So here is the difference between the last definition and this one. So here for every a on I, we have the limit when x gets closer to a equals f of f of x equals f of a. So this is for every a in I, and the limit when x gets closer to b minus of f of x, which is equal to fb, and the limit when x gets closer to c plus of f of x equals fc. So here we have b minus because we are coming from the left hand side, we are going to the left, and here we are going to the right hand side. So if I is open, we only need the first condition. So if our interval here is open, b and c are not included, we are only going to need uh, the limit of f of x equals f of a. So example 2, f of x equals x squared plus 1 for in the interval 0, 1. So let's a be in I. The limit when x gets closer to a of f of x is equal to a squared plus 1, which is equal to f of a. So this is very simple. And then because we have the limits equal to f of a, then f is continuous on I, uh, which is not quite true. well, it's continuous, but we need to verify that the limit when x gets closer to 0 plus and when x gets closer to 1 minus to say that f is continuous. On the other hand, if we take another example, which is f of x, which is equal to 1 over x, and I be the open interval 0, 1, so now 0 and 1 are not included, the limit when x gets closer to a of f of x is equal to 1 over a, which is equal to f of a. And then the limit when x gets closer to a of f of a equals to f of a, which means that f is continuous in a, in I, our interval 0, 1. So the geometric interpretation, a function is said to be continuous if we can draw its graphs without our hand leaving the paper. So if we want, for example, to draw our function x squared here, so we take it from here and come all over here without without our hand leaving the paper. We can write other example of continuous functions, things like this, or I don't know, this, for example. So these are all continuous function. On the other hand, if we take something like this, which comes to this point and then continues here, so it's not a continuous function in this point. So this point is where f is not continuous, but if we take it on this interval, for example, it is clearly continuous because we can draw the graph of f here without our hand leaving the paper. So example of common functions that are continuous. So we have the constant function f of x equals c, where c is a real number. So all these functions are continuous. Polynomial functions f of x equals a0 plus a1x plus 2 plus anx to the power m, where n is in natural numbers, so these functions are continuous on R. Sine and cosine are continuous on R. Exponential is continuous on R, and logarithms are continuous on R plus. So this is it for continuous functions. This is just a general review about them, and we will discuss in details these concepts in other videos. Thank you so much for your time. I hope everything is clear, and you can of course ask your questions in the comment section, and see you the next time. Thank you so much.